4.2 is a continuation of 4.1 where we're wanting to add one more thing to our scattered diagram, and that's called a least squares regression line. Okay. Another way we can call that is best fit line, because for the most part our data, the points themselves won't form a perfect straight line. You'll have a scatteredness going on with some strength based on the linear correlation coefficient. But what we'd like to do is we'd like to form a linear equation, okay, linear model. And that linear model is in the form y equals to, if you recall, y equals mx plus b. It's very similar in this class. We're going to call it y equals ax plus b. Okay. So I'm going to show you today how to find this best fit line using the calculator, the TI-83 and the 84. Both work very similar. Okay, there's one major thing that I do need to show with both. That way everyone is on the same page. But the goal is to find this best fit line. Now again, because the points are going to be scattered, it's not going to be a perfect fit. Okay, so when it's not a perfect fit, we give this y a little symbol called y hat. Okay, y hat. So if you see this symbol y hat right here, that's your best fit line. It's not a perfect line, it's a best fit line that tries to predict the behavior of the data set. Okay, so in example 1, find the least squares regression line, the best fit line, for the bone marrow density versus soda consumption data set. So if you went through the handout, that was the last example in 4.1. Determine if soda consumption is associated with bone marrow, lower bone marrow density. So the more soda we drink, is there an association with a decrease or an increase in bone marrow density? So I'm going to look at the scatter diagram first. Okay, so let's enter the data set into the calculator. So stat, edit. Okay. And if you notice, I have the data entered into L1 and L2. To take a look at the scatter diagram, here we'll go to second mode just in case, and then second y equal. So we can turn on the stat plot. Okay. Make sure that the type is on the scatter diagram, and your lists, if you have your data in L3, L4, make sure that the X list and Y list are entered accordingly in the calculator. And then once you're done with that, you hit graph. Okay. Again, if you can't really see it, zoom number 9 will give you a better picture. Okay. So in this example, okay, there seems to be a negative trend with BMD. The more soda we drink, on average, our bone marrow density may be decreasing. Okay, that's the association here. Now, to kind of get a general guideline as to the strength, because again, for some of us, maybe this is a little bit too scattered, maybe it's not linear. If you recall, okay, turning diagnostic on, okay, so my calculator resets every time, so I have to do this every time. But again, if this is your personal calculator, if you're not resetting your calculator, then you only have to turn the diagnostic on once. Okay. Here, I'll put diagnostic on to the home screen, hit enter one more time. Now I can determine the R value for that scatter diagram. So to do that, once again, stat calc number 4. Okay, and again, if you have the 83 a little bit different, we need to put the X list on the home screen, comma, the Y list on the home screen, and then we hit enter. Okay, now it's giving me a negative number. Should the R linear correlation be negative? Well, let's see. Okay, this seems to be in the negative direction. There seems to be a negative trend, so we should expect the linear correlation coefficient to be negative. Okay, and they got negative 0.96. It's very close to a negative 1, where negative 1 is a perfect negative trend. So it's very close. Now, what I want to do is I want to put a straight line that best fits this data set in order for us to really work with this model. There's a lot of interesting things we can do once we have a best fit line. So let me show you how we actually get the best fit line onto the calculator. So if you notice, whenever we did the linear correlation coefficient to find the R, you went to Stat, Calc, and then you went to number 4, right? Notice what else number 4 says. It says AX plus B, right? And the best fit line is in the form AX plus B. So what the calculator will do is it'll give you what the A is and what the B is. A is known as the slope, B is known as the y-intercept. So when we hit 4 or enter, 83, 84, go ahead and proceed accordingly. Here we need to do L1, comma, L2. But if you notice, the A is given as negative 0.005. So what we're going to do is we're going to fill in with this. So we have negative 0.005x plus the y-intercept. The y-intercept is the B, 0.89, let's call it 0.895. Okay. What that means is this is the best fit model that best predicts the behavior of this data set, that best predicts the behavior of this data set. Okay. So what are some of the things that we can do with this? Okay. For example, we can predict bone marrow density for, let's say, 1.5 cans of soda. Okay. If you notice, 1.5 is not in the data set, right? This was observed data here. But if you're within the scope of the data, the scope of the model, that means I can predict behavior between 0 to 5 sodas, then we can use this best fit model here. So the way we use this, okay, is X is equal to 1.5. So let's best predict the bone marrow density. Y hat is equal to negative 0.005x, which we're calling 1.5, plus 0.895, right? So in the calculator, we'll go ahead and plug in 0.005 with a negative, and then 1.5 plus 0.895, okay? That predicts the bone marrow density for an individual drinking 1.5 cans of soda. So here, 0.8875 is the expected or the predicted bone marrow density for 1.5. Okay, so a lot of neat things we can do whenever you find your best fit line, the best fit model, we can predict behavior within the scope. Now, we cannot predict behavior that's outside the scope of the model. What does that mean? So my observed data set only goes from 0 to 5 sodas consumed. I cannot predict behavior for 5.5. 5.5 is outside the scope of the model. I cannot predict for 6, 7, 8, 9, or 10 sodas either. Okay, but we can predict behavior between 0 to 5. Okay, so that's one of the first things we can do when it comes to predicting using the best fit line. Now, the second thing I do want to show you, I want to see the line on this graph here. Okay, this is where in the calculator it gets a little bit complex, but I'm going to show you how to get the line onto the graph here. Okay, so I'm going to start from the very beginning. Let's clear that. In order for us to draw the line on the graph. So step 1, make sure your data set's in there, L1, L2. Okay. quit to the home screen. And then step 2, stat plot. Okay, make sure your stat plot is on. It's on the correct type, which is the scatter diagram, and then L1, L2. Go ahead and graph. If you need to do a zoom 9, go ahead and do so. Okay, so that's step 3. Step 4 is where now we actually get the line on the graph. So to do so, second mode, and I want you to run the linreg command one more time. Stat calc number 4. Okay. But the way you're going to run the number 4 now, okay, it's in the handout here. Not only are you going to do L1, L2, your X list, Y list, but you're actually going to put another variable on the home screen called Y1. Y1, and you don't have to do this, I'm just showing you. When you hit Y equal, Y1 is there. By placing this variable with the linreg command, linreg will store your best fit line into the calculator for Y1. Okay, and that's what we wanted to do, is we wanted to store the best fit line into Y1. So how do we do that? And again, it gets a little complex, but bear with me. So let's put the X list first, comma. Then we put the Y list, and then comma. If you have the 84, I'll show you how to do that in a bit. But with the 83, you want to do comma after the Y list. And now we're ready to place Y1 on the home screen. Right here in the handout, it shows you how to do so. Okay. Y1 is the regression equation, and if you have the 84, you'll see this reg EQ on your screen. That's where you're going to place that variable Y1. To do so, you hit bars. Okay. Then on top, you'll see the tab YVars. Okay, and then go to number 1, function. And you'll see Y1, Y2, Y3. We're going to default to Y1. We're telling the calculator to place Y1 onto the home screen. So now the linreg has an additional variable. And if you hit enter, it looks like nothing changes, right? Diagnostic is on, so we still have our linear correlation coefficient. We have our best fit line AX plus B, where A is negative 0.005, B is 0.895. But when you hit graph this time, it graphs the best fit line for you. It graphs the best fit line. And remember, we use the variable Y1, right? So what'll happen is now when you go to Y equal, just Y equal, it stored the best fit line here for you. It's very nice. Okay. Now, one of the last things we can do with the best fit line is called residuals. Okay, residual. Because if you notice, if you're looking at this calculator here, this point right here is for 0 sodas consumed. This is for 1, and this is for 2 sodas consumed. Did our best fit line go straight through the observed data point? No. And again, the best fit line is not a perfect line. The gap in between, there's an error with our model. There's an error with our equation. It didn't perfectly predict for 2 sodas consumed. That gap in the middle is called a residual. Okay. And to calculate residual, there's a formula. If you look up here in the handout, observed Y minus predicted Y. So that's what this looks like. Residual is equal to observed Y minus predicted Y. Okay. So the observed Y will always come from the original data set. Okay. This is always going to be the original data set. So say, for example, I want to predict, or I want to calculate the error when X is equal to 2. Okay, find the residual whenever X is equal to 2. Well, when I go to my original data set, okay, 2 sodas consumed, you as a researcher, you actually observed this behavior in the real world. Whenever 2 sodas were consumed, you observed 0.888. So the observed y will be called 0.888. Okay? And then minus the predicted y. The predicted y will always be your best fit line. Okay? So for the best fit, there are a couple of things you can do. To find the predicted y, you can take your predicted, and in here, you'll plug in 2 this time. Okay? When you plug in 2, that's going to give you your predicted bone marrow density for 2 sodas consumed. Now, if you went through the trouble of putting the third variable, that y1, into the calculator, so your best fit line is actually stored in the calculator, then your predicted y you can get from this. By going to second graph, okay, this y1 is your predicted y. So I want to predict for 2 sodas consumed. And according to the calculator, my best fit line says 2 sodas consumed, we're predicting 0.88451. Okay. So this calculation right here, after we calculate, that's going to be our residual, our error, that gap in the graph that exists, that's the residual. So let's go ahead and calculate in the calculator, second mode. 0.888 minus 0.88451. Okay, so we get a residual of 0.003. That's another thing we can do. That gap in between, when we looked at the second data point, that gap has an error or residual of 0.003. Okay. Now notice this point over here now. This point was above the line, right? So we had a gap above the line. This one has a gap below the line. So let's do one more example with the residual. So for 0, 1, 2, 3 sodas consumed, let's look at calculating residual for 3 sodas. Okay, so example, calculate the residual for x equals 3 sodas consumed. So once again, residual has a formula. Residual is equal to observed y minus predicted y. Okay. And the observed y, once again, this comes from the original data. You went out there as a researcher to gather this data here, and for 3 sodas consumed, what did we observe? 0.876. Minus, now we need the predicted y. Predicted y comes from the best fit, keep that in mind. And you can either plug in 3 to your best fit equation. Remember that your best fit equation is this one, right? So it's this one. You can plug in 3 here, 3 here. But to be more accurate, okay, we're going to use the calculator to help us. So once again, in the calculator, y equal, you stored your best fit line. So we're going to use that y1 variable, that was our best fit, to tell us what is the prediction for 3 sodas consumed. So in the calculator, 3 sodas consumed is here. The best fit line predicts 0.87949. Okay. So when we calculate this in the calculator, let's see what we get. 0.876 minus 0.87949. Okay, interesting. Here in this example, we get negative 0.003. we got a negative residual. In the previous one, we got a positive residual, right? So negative, positive, why did that become so? In the graph, it tells you based on the sign where the gap is located between the observed and your best fit, okay? So if you got a positive residual, that means the gap or the error was above your best fit line. If you got a negative residual like we did in the second example, that's because the residual, the gap or the error is below. Those of you with the TI-84, I do want to show you for the third variable, the y1, in order to save the best fit line into your calculator, I do want to show you how your screen looks like. It does look a little bit different. So let's take a look. So suppose you have your data. Okay, so this is your data here in L1 and L2. So when you go to Stat, Edit, we'll assume it's there, L1, L2. And when you're ready to run the linreg function, you'll go to Stat, Calc, and number 4. And we've seen that your screen does look different. Okay, so for the X list, we want it to be the soda consumed column. The Y list, we want that to be the bone marrow density. Now, when you go down, you will leave frequency list as is, and you want to go down to where it says store regression equation. Okay, so this is where you want to place Y1, where Y1 is your best fit line. Okay, so to do that, you'll hit vars, Y vars, number 1, and press enter on the Y1, and what you'll see is that Y1 will be stored as the regression equation. From there, you're ready to calculate, and then you have your best fit line.